Welcome to aminacademy.com. In modular arithmetic, let us discuss about multiplicative inverse, some solving problems. In modular arithmetic, particularly in the area of arithmetic, a modular multiplicative inverse of an integer a is an integer x such that the product ax is congruent to 1 with respect to the modulus m. In the standard notation, the modular arithmetic, this congruence is written as ax equal 1 mod m, with the shorthand way of writing the statement that m divides evenly the quantity ax minus 1, or put another way, the remainder after dividing ax by the integer m is 1. For example, given two integers a and m, find the modular multiplicative inverse of a under modulo m. The modular multiplicative inverse is an integer x such that ax congruent to 1 mod m. This is a general way of writing modular arithmetic for inverse. The value of x should be in the range 1, 2, 3 up to m minus 1, because mod m, the range is 1, 2, 3, 4, 5 up to m minus 1. That is in the range of integer modulo m. Note that x cannot be 0, as a star 0 mod m will never be 1. The multiplicative inverse of a modulo m exists if and only if a and m are relatively prime, that is GCD of a and m must be equal to 1. Multiplicative inverse modulo. Let us see some of the methods to the proof modular multiplicative inverse. The modular multiplicative inverse of an integer x such that ax is congruent to 1 mod m. The value of x should be in the range 0 to 1, 2, 3 up to m minus 1. Already you have seen, that is, it should be in the ring of integer modulo m. Note that the modular reciprocal exists, that is a modulo m if and only if a and m are relatively prime, that is GCD of a and m equal to 1. This is the first method. The method 2 tells us if a and m are co-prime, multiplicative inverse modulo can also be found using the extended Euclidean algorithm. From the extended Euclidean algorithm that takes two integers to say a and b, finds their GCD and also find x and y such that ax plus by equal to GCD of a comma b. To find the reciprocal of a under m modulo m, substitute b equal to m in the above formula. We know that if a and m are relatively prime, the value of GCD is taken as 1. Therefore, you can say ax plus my equal to 1. Take modulo m on both sides and we get ax plus my equal to 1 mod m. We can remove the second term on the left side as mod m, because for an integer y will be 0, so it becomes, that is my mod m can be formed as y will be 0, so it becomes ax equal to congruent to m mod m. So the value of x can be found using the extended Euclidean algorithm also. It will be discussed in next videos, which is multiplicative inverse of a. Now we will do some simple examples for finding inverse. Find phi inverse mod 7. Here first mod 7 is, that's the first we will write 7 plus 1 is equal to 8. We know that because mod m adding 1, which is not co-prime. 5 and here 5 comma 8 are not co-prime. So we have to, next multiple of 7 is 7 into 2 is 14 plus 1 equal 15. Therefore here 5 and 15 are co-prime. That is the multiple of GCD of 5 and 15 is not 1. So therefore we can say, since look at here, 3 into 5 equal 15. Therefore you can say that 5 inverse equal 3 mod 7. Next question, 45 inverse mod 89. The second part here, 89 we take now. 89 is add 1. 89 add 1 equal to 90. And we can say 45 and 90 are co-prime. So you can say, therefore you can say 90 can be expressed 2 into 45. Therefore 2 into 45 is 90. Therefore we can say 45 inverse equal 2 mod 90. No, this is wrong here. Therefore you can say, since next question, prove that 25 does not have multiplicative inverse of mod 30. Now we can say 25x equal 1 mod 30. For sake of simplicity, we are keeping it have inverse, 25 as inverse, but controversial, we have to do contradiction, you have to say it is not. That here 25x equal to mod 30, then 6 into 25 equal, multiply 6 both sides, mod 30, then 6 into 25 is 150 is into here, 150 x here, 150 x equal 6 into 1 is 6 mod 30. Therefore if we divide, that is 6 is 150 is a multiple of 6. Therefore you can say the remainder here 0, because 0 is 6 mod 30. This contradiction, this is a having contradiction by contradiction. By contradiction we can see there is no such x values, so x 25 does not have multiplicative inverse. Therefore 25 does not have multiplicative inverse of mod 30. That means here you are not getting any value other than 0 here, because 150 is multiple of 6, that is 150 multiple of 30 also, and we are getting 6 is a quotient here. Here this is a contradiction because it is not true here. So far I have done some explanation about modular inverse, and we did some example problem. We have done. Please subscribe our YouTube channel.